Welcome to Python Regularization. Rocket. Today, you will learn how Ridge, Lasso, and ElasticNet make your machine learning models better. No experience needed. Let us start together and explore the basics of regularization step by step. Running the cell now. What is regularization? Regularization helps models avoid overfitting when a model remembers too much from the training data and performs badly on new data. Ridge and Lasso are two popular regularization methods, and ElasticNet mixes both. Let us see how it works in Python. Running the cell now. Let us keep the notebook clean by hiding warning messages. This first line lets us use code comments for clarity. Comments are not run by Python. We import the warnings library. Import means we borrow special tools built by others. We turn off warning messages here. This makes output easier to understand. Running the cell now. Let us load real-world data to explore regularization. California housing is good for this. You will see rows as houses and columns as features. This is a comment to say what comes next. We are setting up the data. We bring in the California housing dataset directly with scikit-learn. We also use pandas. Pandas is a tool for handling data tables. Now, we load the data with the fetch command. We make a data frame. This is like an Excel table in Python. We print the shape. This means how many rows and columns we have. Let us take a look at the first few rows to see what the data looks like. Running the cell now. Take a moment to see what the data contains. Why do you think having many columns could be a problem for a model? Understanding the target column helps us know what we want to predict. This is a comment showing what this cell does. We check the basic stats of the target variable. This tells us the price range we are predicting. Running the cell now. Splitting data, train and test sets. We want to train our model on one set and check if it works on new data. Let us split the data into training, used to learn, and test, used to check. Running the cell now. Let us create training and test data so we can see how our model does on new houses. This comment explains, split data into input and what we want to predict. We drop the target column to keep just the features. Here, why is the target column by itself? Now we import train_test_split to make this easier. We split the data, keeping 20% for testing. The random state keeps results the same for anyone who runs this. Last, we print the train and test shapes to confirm the split worked. Running the cell now. Plain linear regression, no regularization yet. First, let us see what happens if we build a simple linear model with no regularization. This is the starting point before applying Ridge or Lasso. Running the cell now. Let us fit a linear model the classic way before we apply any regularization. This comment reminds us we are building a basic model. We import the linear regression class. It makes a model that tries to fit a straight line to the data. We create a model object called linreg. We fit, or train, the model with training data. We check accuracy on the training set. R² or R² shows how well the model fits. Higher means better fit. We also check accuracy on the test set. We print both results to see if there is any gap. Large gaps could point to overfitting. Running the cell now. Notice the difference between train and test scores. Would you expect these to always match exactly? Ridge regression, L2 regularization. Ridge helps stop the model from caring too much about any one feature. It adds a penalty if the model's weights get too big. Running the cell now. Now, let us apply ridge regression to see how regularization changes things. This comment says we are making a ridge model. We import ridge from scikit-learn. We set up a ridge model. Alpha is a regularization strength. Higher means more penalty. We fit the ridge model on training data. Again, we check accuracy for training data. And for test data, we print both. Now, compare ridge results to linear regression. Running the cell now. Try changing the alpha parameter and watch what happens to the scores. Do you see any patterns? Lasso regression, L1 regularization. Lasso is another way to keep models simple. It can shrink some weights all the way to 0, removing unhelpful features. Running the cell now. Let us try Lasso now and see the effect on results compared to ridge and plain linear regression. This comment reminds us we are using Lasso. We import Lasso from scikit-learn. We set up a Lasso model. Again, alpha controls regularization strength. Let us fit, or train, this model. We measure training accuracy and test accuracy. Finally, we print both scores for Lasso. Running the cell now. Compare how Lasso, ridge, and linear regression scores differ. Can you explain why they change? ElasticNet, mix of ridge and Lasso. ElasticNet combines ridge and Lasso penalties. It is useful when you think both zeroing out features and shrinking are helpful. Running the cell now. Let us see how ElasticNet mixes things from both ridge and Lasso. The comment sets up ElasticNet. We import ElasticNet from scikit-learn. This model uses alpha for strength and L1_ ratio to mix Lasso and ridge. 50% means equal mix. We fit, or train, the ElasticNet. Get training score. Get test score. Print both scores. Now, compare to the other models. Running the cell now. Comparing model coefficients. Let us look at the coefficients for each model. The bigger the coefficient, the more that feature matters in the prediction. Running the cell now. It helps to see which features are most important for each model. The comment says we will put the coefficients together. We create a data frame holding feature names and model coefficients. Each column shows the values for a different model. Now you can see at a glance which features are big or small in every model. This helps understand what regularization changes. Running the cell now. Do you notice any zeros in the Lasso or ElasticNet columns? Those features are turned off by regularization. Take a moment to guess which data column is most important for house value. This comment is for you. Try to connect the coefficient table to what you know. This asks you to type a guess. Typing helps you remember better. This line thanks you for participating and encourages you to keep watching. Running the cell now. Try it out and see if you are right. Best practices: choosing alpha. Picking the right alpha is important. If alpha is too high, the model may underfit. If it is too low, the model may overfit. Try different values and use validation data or cross-validation to choose the best one. Running the cell now. Let us see if lowering alpha in ridge helps or hurts the test score. This is a basic experiment with a lower alpha. We create a new ridge model with alpha set to 1/10. Train it on the same data. Print the test score. Compare to what you saw earlier. Running the cell now. Cross-validation helps us choose alpha by testing different splits of the data. Cross-validation breaks data into several parts to check results. We import cross_val_score, which does the splitting and scoring. Here, CV equals 5 means we test 5 chunks of the data. Printing the average gives a better center performance and avoids random lucky or unlucky splits. Running the cell now. Try changing alpha and watch how the average score responds. Which alpha gives the best average for you? Mini project, predicting with regularized models. Let us build a mini project. You will train a Ridge and a Lasso model, then predict values for the test set. You will compare their mean squared error, or MSE, to see which one is better for this data. Running the cell now. Let us fit fresh Ridge and Lasso models and get predictions for the test houses. A comment for context, we are fitting both models and preparing their predictions. Set up Ridge with default alpha. Set up Lasso with default alpha. Train Ridge on training houses. Train Lasso on training houses. Use Ridge to predict house prices on test data. Do the same for Lasso. Running the cell now. Now, let us measure the errors from each model using mean squared error. This comment says we will measure and compare errors. Import mean_squared_error, a function that tells us how far off the predictions are. Get error for Ridge. Get error for Lasso. Print both errors for Ridge. Print both errors for Lasso. Lower is better in this case. Running the cell now. Which model gave you the lower error this time? Try adjusting alpha or features to see if things improve. Challenge, try ElasticNet with a custom L1 ratio. Set the L1 ratio to 0.8 and see how the ElasticNet model error compares to Ridge and Lasso. Which one is best for mean squared error? Running the cell now. Give it a try and share your result in the comments. If the lesson helped you, please like and subscribe to our YouTube channel. Recap. Regularization helps avoid overfitting by making models simpler. Ridge keeps all features but shrinks them. Lasso can remove useless features by making their weight 0. ElasticNet combines both. Remember, alpha is your tuning knob. Test different values and compare results. Running the cell now. Thanks for joining the lesson. For more fun Python tutorials, subscribe to our channel and check out the next videos. Happy coding! Party popper! Running the cell now.